In this experiment, we will use a stock amine substance and 3 dilutions of that substance, each with their own concentrations. Now we will fill 4 cuvettes, each one with one of the substances from the 4 beakers. We will use these cuvettes later in the spectrophotometer.
Beer-Lambert's law is an equation we will use to relate absorbance and concentration. The equation uses the 4 variables of absorbance, molar absorption coefficient, concentration, and the length of the light path through the cell. Using this equation, we understand that absorption and concentration have a positively correlated relationship. Lambda max is the wavelength that gives the highest absorbance. Here are 2 examples of graphs that show scanning across all wavelengths. The highest peak is the lambda max. As seen in the examples, using the wrong wavelength or a shorter peak will result in an inaccurate absorbance.
Here we are using a cuvette that contains only water. This will zero the machine and make sure that when the other substances are read, only the concentration of copper amine is accounted for. Failing to zero the spectrophotometer will give an inaccurate absorbance.
Here we are obtaining the absorbance of the stock solution. We will first wipe the 2 sides of the cuvette and then place the cuvette into the spectrophotometer. The clean sides are facing the beam. For closing the lid, we will press the read button to get the absorbance and then record it in our lab notebook. Now we will open the lid and carefully remove the cuvette.
This process will happen 3 more times, so sit back and enjoy the redundance. Finally, we have made it to the unknown. We will use the exact same process as before to obtain an absorption value. We will then use all of our previous data points to draw a graph and create an equation that will be used to determine the concentration of the unknown.